Hello guys, and welcome to this tutorial on getting started with Kotlin, on developing in Kotlin, right? So we're going to focus here on the basics, the very foundation of Kotlin development. If you've never worked with Kotlin before, if you, let's say you come from another software development language and you want to learn how to build stuff in Kotlin, let's say you want to build some applications on Android or things like that, then obviously you need to get started with Kotlin. You need to have an idea of how it works. It's very, very similar to Java, but there are some important differences. All right, now before we get started, I just want to mention that this is part of a much larger course that I have built for Kotlin development particularly. So if you're interested in that, have a look in the description down below. It has more than 30 hours of content specifically tailored for getting started and mastering Kotlin development, okay? Much more than I can fit into one YouTube video. But here I'm gonna give you some introduction concepts to get you started with developing in Kotlin. All right, so without further ado, let's get into it. Now, first of all, I'm going to use here the IntelliJ editor, okay? You might want to use another editor. For instance, you might have Visual Studio Code or simply a normal editor. I'm going to use IntelliJ because it provides a lot of functionality that I do need and I do like. It's very similar to Android Studio. In fact, it's built on the same foundation. Okay, so if you want to use the same one, go right ahead. If you want to use a different one, that's perfectly fine. Everything I talk about here can be built in other development environments as well. If you don't have IntelliJ IDEA installed, simply open up a Google page, search for IntelliJ. Okay. That will take you to jetbrains.com/idea. Okay, go ahead and click on that, then go ahead and download. Now make sure you choose the community edition because the other one is paid, but the community edition is obviously free, open source. You can use it as much as you like. You can develop professional commercial applications with it, so go ahead and install that one, download and install. If you don't have Java installed, this is also a requirement, okay? So Kotlin does work on the JVM, on the Java Virtual Machine. So if you don't have Java installed, again, simply search install Java. Okay, that should take you to an Oracle page. So down, there we go, Java Oracle. Actually, you know what? Don't search for that. It's better if you install Java JDK, okay, Java Development Kit. Now we have a Oracle page here. Okay, go ahead and accept that. I have Oracle JDK. That's what I'm going to download. And then you have Java SE Development Kit, okay? And down below here somewhere, you will find your operating system, right? Linux, macOS, or Windows. Go ahead and download that, install it. Everything you need will be set up, and then you can start using IntelliJ. All right, so once you have that set up, let's go ahead and create a new project. Now, I'm going to choose here Kotlin on the left side. This is installed by default, so you can simply start using it. I'm going to give it a name, Kotlin, let's say tutorial. Everything else stays exactly the same. We don't really need anything else. And I'm going to click next and then finish. Okay, so we're just gonna let that build for a second. Basically, this will provide you a project with a lot more functionality than we actually need. Okay, so here we will have, for instance, Gradle, which you don't need to know in order to use Kotlin. You do need to know that, or at least have some idea to develop Android applications. But for Kotlin, the basics, we can learn it without knowing Gradle. Okay, so don't worry about that. The only thing that we're interested here is the source folder in the main Kotlin folder here. Okay, here's where we're going to create our file. So I'm going to go ahead and right click new Kotlin file. We're going to need only one file for this particular tutorial, and I'm going to say here Kotlin tutorial. Okay, hit enter. All right, so we have a blank slate. So the first thing I want to do here is I'm going to print out a hello world message. This is obviously customary when we're learning a new language. So how do we print out a hello world in Kotlin? Well, it's quite simple. First of all, we're going to define a function. Now, we're going to talk about functions a bit later on in this video, okay? So don't worry about that. I'm just going to type it here, and then we're going to leave it there as it is until we get to that particular moment, okay? So we're going to say fun for functions. Here we're going to have main, the name of our function, 2 parentheses, and then curly braces, and that is our function definition, okay? Now here, in order to print a hello world message, we're simply going to say print ln, which is print line, okay? It's going to put a new line at the end, okay? And inside here, we're going to say hello Kotlin, or hello world, whatever you like. All right, so that is all we need to do, okay? Let's go ahead and right click and go ahead and run Kotlin tutorial KT for Kotlin extension, okay? I have my presentation assist here, so if I do something and you don't know what I do, this should print out that information. All right, so that is all we need to do to print out a hello world message, hello Kotlin message. Now, here is a quick challenge for you. Go ahead and change this printout to, instead of Kotlin, print out your own name. Okay, go ahead and do that. Pause the video and continue when you finish. All right, so I'm assuming you have done that. Congratulations. Basically, it's very simple. We're going to simply change Kotlin here from hello Kotlin to hello your own name. Okay, I'm going to say Alex. So hello Alex. Okay, running that, we should get a output hello Alex. So that's very well and good. We have a way to print out messages to our console, to our users, or if you're working on a large-scale application, to whatever output environment you might have. Okay, so now I want to talk about a few different things. I have here a quick curriculum that I've put together just for me to have as a reference. All right, so next up, we need to talk about comments. Now, comments are obviously a very useful way for developers to clarify their code, to let other developers know what this particular piece of code does. Okay, very, very useful, very underutilized functionality by different developers. Nobody likes to comment their code, but they are quite useful for developers that are reading the code itself. Okay, so how do we do comments in Kotlin? Well, it's quite simple. First of all, let's say this prints out a hello message. Okay, so this is a comment. Now you can see here I get a compilation error because it's not considered a comment so far. But the first thing I need to do is put a // at the beginning, and this will mark it as a comment. This will basically not count in the program at all. Okay, another very easy way to do that, and this is specific to this environment, to the IntelliJ IDEA environment, is to simply hit Command / on Mac or Control / on Windows. Okay, you can see here the description. Basically, this comments out a certain line. Okay, if I do it, and you can see the cursor move to the next line. So if I do Command / and Command / again, it will comment multiple lines. Okay, so this is the standard comment here, but there is of course another way that you might know already. So another way to do comment is to put multiple line comments, and that is done with the /* comment. Okay, so that is a multiple line comment. So this is a multiple line comment. Okay, so you can put here as many lines as you want. Okay, very, very easy. And this is especially useful for commenting functions and providing documentation for your larger functionality, not just line-by-line commenting. All right, so that is the comment. Now let's move on to what do we have here? We have variables and strings, okay? Now let's talk about strings first. So a string is basically a chain of characters, okay? We have used chains of characters here, okay? This is basically a string. Println is a function, and we give this function a string, and the function does whatever the function does with that string. So let's, instead of this string, let's go ahead and put this string into a variable, okay? So in order to define a variable, we're going to type val and hello, or let's say message equals, and I'm just going to cut and paste this one here, okay? And replace the print line with a message, with my variable message, okay? So what have I done now? I've basically defined a variable. A variable is basically a container, right? That will store some information. In our case, it will store a string. Okay, so the message will be part of this variable. Now you can see that the keyword here is val. We have two keywords for variables in Kotlin. We have val and we have var. The difference between the two is that val is a value, okay? It's kind of a variable, but it's a value in the sense that it cannot be modified once we have created it, okay? However, the var can be modified, okay? So we have here hello Alex, but if I modify it to message, to message equals hello Judy and printline it, we can see that the variable has in fact been modified, okay? That allows us to change the message. If I put val here, I will get a compilation error saying val cannot be reassigned, okay? So very, very important difference. We use both in development, we use both var and val, okay? I think I try to use val as much as I can unless I need that value modified. Okay. Now, next up, we have strings. Okay, so basically, strings, like I said, are a chain of characters. Now, here is where something interesting happens. We can change strings in different ways. So for instance, let's say I have a message, or let's say I want to print line message plus space and John. Okay, so what will happen? My string plus another string will make a larger string, obviously, okay? So very intuitive, but it's very important to know that this does work. Also, something interesting here, we have print line. How can we provide, let's say we have a variable name equals Michael. And we want to say whatever this variable name, let's say it comes from another place, from another function. Let's say we have hello. Now we want to introduce that name here. So there are two ways to do this. First of all, we can say hello plus name, okay? And that will give us Michael. But there is a better way. I just hit Command D to duplicate the line. Instead of doing it like this, it's more elegant actually to put the variable inside the string with a $sign before it and say hello name, okay? And that result is the same, okay? And this is even better if we have, let's say, name1 and name2, and here I say Carol. Let me change this, okay? And put another variable here, name2. Okay, so you can see how we can construct strings like that with the variable with the variables inside it, preceded by a $sign. Okay, so we get hello Michael and Carol. All right, now we have, let's say we want our strings, our output, to contain some particular characters. Now you can see the strings are bordered by double quotes. Okay, this is quite important. if we put a double quote somewhere here, that will end our string. But what if we want the output string to contain double quotes? Well, we can do what we call escape the characters. Okay, so we can say here, instead of double quotes, we can put / double quote, and that will print out a quote in our output. So I'm going to put one here as well. And if I run this, what will happen? I get hello Michael in quotes. Okay, so you can see the printout was quotes and Carol. Okay, now another question. What happens if I want to print / quote here? Okay, what happens then? When we, of course, have an escape functionality for that, we have a double /. Okay, so I have a double / something like this. That will simply print out a / in the output. Okay, so these are escape characters. Now we have other escape characters. I'm not going to go through all of them, but for instance, we have /t that will put a tab here, and there are a few others that are not that commonly used. Okay. Okay, a few more words about variables. Now, the variable names here. What can you name a variable? Well, basically, you can name it anything that has lowercase letter, uppercase letters, you have numbers or underscores. Now, the important thing is that it starts with either a letter or an underscore. It cannot start with a number, okay? So if I try to define a variable 3 cats, that's not going to work. Okay, that's not going to work. I can do underscore 3 cats. Okay, so that is fine. I can do my 3 cats. That is also fine, but 3 cats, no, that's not going to work. It has a number as the first character here. Okay, now the basic convention is camel case when defining variables. Okay, so if you have a variable that consists of multiple words, you use camel case. So that means the first word is lowercase, but the next words are, the first letters are going to be uppercase. So what does that mean? So let's say my first variable storage unit. Okay, so you can see here that it starts with a lowercase letter, but every other word is capitalized afterwards. Okay, so that is, let's say, database. That is the standard convention. Okay, you don't have to follow it, but it's simply a convention. Okay, a lot of people use it. Right, so I wanted to add another thing. When we have this kind of usage of a variable, okay, so let's say I go print line. Let's say I want to print line the length of the name, okay, so length is going to be, now if I do, the way you get the length of the name is, you can say val length equals name1.length, okay, very simple. Now either I could print $length here, okay, but there is a simpler way. So let me just delete that. Now, instead of length here, I'm going to put $name1.length. Now, see what happens here. If I hit enter, it's automatically going to put curly braces between my expression here. Okay, so my expression will be contained by curly braces if it is inside of a string. Okay, so that is how we print out something a bit more complex than a simple variable in a string. Okay, so that is also quite useful for building up strings. All right, so that's pretty much it about strings. What else can I say? Oh, let me show you how you can get some information from the user. Okay, so let's ask the user for something. So let's say val user input is going to be, how do we ask that? Well, we have a function for that. We have read line. Okay, that's going to allow the system to read some information from the user. And then let's go ahead and print line that user input. Okay, let's go ahead and run that. Okay, now here it is expecting some input. So let's say bananas. Okay, so I've printed out, let's put here, instead of user input, you said user input. Okay, now it might be useful when you do that to have a message for the user. Please enter something. Okay, now we let the user know that we are actually expecting some information here, and we can say, let's say oranges. You said oranges. Okay, so that's a way to read some information from the user. Okay, let me see what else is here. All right, so let's talk about numbers. Okay, numbers obviously very important in software development. Now, what kind of numbers do we have? Well, obviously we can say val count equals 5. Okay, so that's a number. And if I do print line count times 3, that's obviously going to give me 15. Let me just comment out this code so that it doesn't run every time. Okay, so that's going to give me 15, obviously. So this is a number. This type of number we call integer. Okay, so integers are a type of numbers. Okay, but we have actually multiple types of numbers. We have about 6 in Kotlin. Okay, so we have byte, we have integer, we have long, we have byte, short, integer, long, float, and double. But all of these kind of go up in size. So byte will only take 8 bits. Okay, so 2 to the power of 8, I think, right? So that's quite limited, and we don't really use that too much. Short is kind of the same. I think it goes to 2 to the power of 16 or something like that. Next is integer, which is kind of the default number, which goes to 2 to the power of 32. Okay, that's on both sides of 0. Okay, so 2 to the power of 31 positive and 2 to the power of minus 31 to the negative, right? So on both sides. And then we have long, which I think it's 64 or 128. I'm not really sure, but that is quite long. Okay, so here, let's say we define a few numbers. Okay, so we have val items equals 3. That's going to be an integer. Let's define a long. So let's say population equals 7,500,000,000. Okay, so that's going to be a long. Here's an interesting thing. You can actually put underscores in your numbers wherever you want, just for clarity. Okay, so underscores are kind of ignored, but it's useful for the reader actually here. Next up, we're going to define a price. Let's say $29.99. Okay, so that's going to be a double. Okay, double is basically a number with a decimal point. Okay, that is very large. Float is the same as double, but smaller. Okay, if we want to define a float specifically, we shouldn't necessarily want to do this because double is larger and useful in most situations. But if we want to, let's say we might have a memory limitation. Okay, so we want to use the smallest numbers possible. Let's define pi dot equals 3.14159. And if we want it to be a float, we need to put a lowercase f at the end. Okay, let's check the types of these numbers. Okay, so let's go ahead and print line. Let's say I'm going to have here $items is. Now, how do we get the type of a number? We have, let's say items, $items, : class. Hold on, let's put the curly braces because it doesn't do it automatically for us. Items : class.java. Remember, Kotlin is based on Java. So here we want to get the class of items. Okay, let me duplicate this another 3 times. I'm going to have population. Okay, I'm going to have price. And I'm going to have pi. Okay, let's go ahead and run this. Okay, so 3 is an integer. You can see here int. We have long. Like I said, the underscores are ignored by the system. Then we have double and we have float. Okay, so these are kind of the numbers that we do use. Now, let's say we want to define a short number, okay? And the reason I show you this is not because it's quite useful to define these kind of numbers, but I want to show you how you can explicitly ask for the type of number that you want, okay? In this situation, what we did is we kind of implied the type based on the value that we give it, okay? So Kotlin isn't really bothered. It just takes the most appropriate type. Of course, you could use float for this one, let's say, okay? But it's more appropriate to use an integer since this is basically an integer, right? So the system doesn't really care about that. It just assigns the most appropriate type by default. But let's say we want an explicit type, okay? In that case, we can have val items, or rather, let's say price equals. Now, if we want to define the type specifically, I'm going to say colon float with a capital F equals 3. 3f. I've already defined the price, so I'm going to say price2. Okay, so here I have price2. It's now a type of float. Okay, we can see 3 here. Okay, so that is how we define it. Now, if we want to say, let's say val new items equals, let's define it as a short, and here we have 8. Okay, so this is forced to be a short. Okay, so I'm gonna print line this as well. Let me just copy a print line from here. New items, copy, paste, and paste. Let me run that, and now we should get a short for this one. So I forced it to be a certain type. Now, this is quite useful. The reason I'm talking about this is because it's quite useful for the system to know certain types that you need, okay? In, for instance, object-oriented programming, you can have multiple subtypes of a certain type. So that means we need to define the type specifically, okay? Or for instance, if we just define a variable without a value, what we will see later on. We will see later on how to do that. If we want to define a variable without a value, then we need to define the type as well. So very, very important functionality here. Now, sometimes you might want to dynamically switch or convert from one type to another, okay? Let's say we have new items of type short, but later on I realized, look, I need a float here, let's say, okay? So here, what happened? Okay, I deleted this by accident. Let's say I want to convert from float to, from short to a float. So how would I do that? So I say val new items float is going to be new items dot to float. Okay, we have a functionality here. We say dot to float, and that will simply convert it to a float. Now, conversion is quite tricky sometimes because here we are converting a short, which is a very small type, to a float, okay, which is a very large type. Okay, so there's no problems here. We will just get 8.0 as a float. But what if we try to convert, let's say, convert this pi value to an integer? What happens there? Because integer is more restrictive than float. So that means we will lose some information, okay? We won't have the decimal point. So let's try to print that. Here, let's say pi dot to integer. Okay, let's run that. And we get 3. So we have actually lost some information when we did that conversion. Remember, you as a developer must make sure that it's appropriate for the program if you want to lose some information or not. Okay, some conversions cannot be made, especially let's say object-oriented programming. Okay, if you define your own types, you're not necessarily going to be able to convert between the two, either unless they inherit from the same class. Okay, you probably know this about object-oriented programming, but in simple cases like this, in simple types, yes, you can convert, but it is your responsibility as a developer to make sure that that is appropriate for your code. Okay, so that is conversion: to int, to float, to double, and so on and so forth. You can also convert to string. So for instance, here we might have print line, let's say pi.toString, and it will obviously print the pi value here. Now notice here that pi.toInt will give us a result, but will not actually change the pi variable. Okay, so very, very important, because when we use it later on, we still get the correct value. So this provides us a result. It doesn't actually change the variable. Okay, very, very important. All right, what can we talk about? Let's talk about some arithmetic operators for our numbers. Okay, so we have multiple operators. We have obviously print line, let's say 3 plus 6. Okay, so that is the addition operator. We have 3 minus 6, we have 3 times 6, and we have 3 divided by 6. Okay, obviously you should be able to guess what these are, or calculate rather. Okay, so nothing really unexpected here. The only one that might be a bit tricky to understand if you've never used it before is print line, let's say 10 modulus 3. Modulus basically gives you the remainder of the operation. So if you divide 10 by 3, you get 3 and a remainder of 1. That's going to be the result of this operation. Okay, so there we go. So we get 1. That is the percent operator, or the remainder operator. We also have the increment and decrement operators. Okay, so here, let's say we have 6. The increment operator is plus plus. That obviously works better on a variable. So let's take items plus plus. Value cannot be changed. Okay, so let me make it a var. Okay, so items plus plus, basically plus plus will increment the value. Okay, so it's different from the transformation here. It just increments the value itself and returns that result. Okay, so running that, we should get items is now 3. Now, there is a very specific reason why we get this 3 value here, and it's quite subtle. The position of the increment operator influences the result. So if we put the operator at the end, it means that the value will be used and then the incrementation will be done. If we put plus plus at the beginning, it means the increment will be done first and then the value will be used. So if we run it now, we should get a 4 as an output. Okay, and then the value of items will become 4. Now, if we do the same thing, but with minus minus, let's say new items, that's also a val. I'm gonna put var here. Let's go ahead and run this, and then we get 7 instead of 8. Okay, so increment and decrement operators. All right, now let's talk about assignment operators and augmented assignment operators. So the assignment operator is basically what we've used so far, is the equals sign. This means the value on the right is assigned to the left, to the expression on the left, be it a variable or whatever it is, right? So that is the assignment operator. We've used it before. Now, we also have the augmented assignment operator. Let's say we have here, let's say pi plus equals new items. Now, it doesn't really make too much sense. I need to change this to var. It does make too much sense to add new items to pi, but there we go. It's just values at this point. So basically what this says is pi is going to be value of pi plus new items, and we're going to assign it to pi. Okay, so I'm not sure the value of pi at this moment is 4, and items is going to be 7. So 4 plus 7 is going to be 11. So print line, let's print line pi. Okay, there we go. So right, so it maintained, no, we didn't change pi, we changed items. So pi is going to be 3.14, new items is going to be 7, okay, from here. So that's going to be 10.14, print line. Now, if we do the same, but with the decrement augmented operator, okay, so pi minus equals new items, and we print line pi, okay, and then we get back to 3.14159 for our value. Okay, so these are the augmented assignment operators. Now we also have operators. So we also have our logical operators. Okay, logical operators basically perform a logical operation between two expressions on the left side, right side, right? So let's say print line, we have a value true and true. So the AND operator returns a true if both expressions on the left and the right are true. Okay. We also have the OR operator, which simply returns true if one of the expressions is true. The other one can be whatever. Okay. So let's go ahead and let me just duplicate this. Here, let me put AND. Let me put here false or false. That should give us a false result. So let's go ahead and run this. Okay, true for the first one and false for the second one. If I put true here, running this, we get true. Okay, so and or. Okay, both very logical. We also have the not operator or the negation operator. Here we have not false is going to be true, obviously, right? So let's see, true, and if I put not true, that's going to give me false. That's very simple. All right, what else do we have? We have some comparison operators. Comparison operators basically compare values of numbers. Okay, so let's say print line is 5 greater than 3. Okay, it's not, so that should give me a false. Sorry, a true. 5 is greater than 3. If I put 5 smaller than 3, that's going to be a false. So that's going to be false here. Okay, we also have smaller than or equal to. Okay, so if I put 5 smaller than or equal to 5, then we get a true. And obviously we have greater than or equal to. Okay, true. Now we also have equality. So let's use a variable this time. Let's say, what haven't we used? Price. Okay, so price equals, so this double equal sign will basically check for equality. Okay, so price double equals 29.99. Okay, let's go ahead and run this, and I get true. Okay, so greater than, smaller than, and equality. Very, very simple. And of course, since we have equality, we have also not equality. Okay, exclamation mark equals, that's going to give me a false. Okay, false. So these are the operators. We have arithmetic operators, we have logical operators, and we have comparison operators. Very, very simple and easy to learn. All right, nullability. Now, this is a very important topic. Nullability is one of the key aspects, the key advantages of Kotlin, okay? The null value has been called the billion-dollar mistake, okay? Because a lot of software development languages allow for null values, and they cause a lot of errors in operation, okay? The null pointer exception is one of the most common, one of the most annoying, and one of the most difficult errors to find and fix, okay? A lot of bugs and a lot of frustration have come from this. Now, Kotlin provides a way by default to prevent rather, null pointer exceptions, okay? They are completely eliminated by the design of the language, okay? So we don't really need to do much to avoid them. We just need to know how the system works to eliminate these kind of errors, okay? So obviously we can define variables with a null value in Kotlin, okay? So let me say val, let's call this cat name. Now here, I cannot say simply equals null, because that will give me a type. Let's put a var here. That will give me a specific null type, and I don't want that. This variable basically is unusable after that. So what I can do is I can define this cat name as a string, okay, that can take the null value. And I'm gonna let the system know that this variable can have a null value, okay? How do I do that? I say :string, and I put a question mark here. So this basically says this variable can have a null value, and in fact it is null by default, okay? But then I can say cat name is fluffy, okay? So I have assigned a value to it. Now here the issue for the system is that this cat name, even though the value is fluffy, the system knows that it can have a null value as well, okay? So let's go ahead and try to print line this variable. So if I say cat name, that should work fine. I'm gonna run it, okay? And I get fluffy. Now, what happens if I try to get the length of this string? So if I say .length, okay? Now you can see that the editor has marked this as a smart cast because, you know, we're using a very, very simple example. And the editor knows that this is in fact a true value now, a correct value. However, if I put here cat name equals null, because the value can be null, then I get a compilation error. And here we say only safe or null asserted calls are allowed on a nullable receiver of type string. Okay, so what we did here is we have defined a string that is nullable, and the system is telling us, look, this is nullable. I don't know, let's put quotes around that. I don't know what value this variable has, therefore I'm giving you an error. Now, in this particular situation, since I haven't introduced functions before, we're going to go with this small example. And in this small example, the editor is smart enough to recognize the value here, okay? But if I comment this out, and let's assume that this comes from some other process outside of our control, then this needs to be handled. This null pointer exception that is possible here in other software development languages, in Kotlin, it is not allowed. Now, how do we fix that? Well, we say :length. Now, if we put cat name .question mark, it simply means that if there is a value there, we get the length. If there is no value there, we get null. Okay, so we have eliminated this null value, okay, because print line can actually handle null values. Now, if we want to chain these operations, okay, if I say .toFloat, okay, let's convert that to a float, you can see that we are chaining these operations together, and I'm getting another error message here because this has been solved, but now length can be null as well, okay, and I cannot apply toFloat to a null value. So again, I have to provide the value here, question mark. Okay, so that is the null safety functionality in Kotlin. Now we have two more operators we need to discuss. So first of all, let's say I want to print line my cat name. But whatever happens here, I don't want a null value, because let's say a final user might see this functionality, and I don't want a null that doesn't mean anything to a regular person, right? So what happens if I want to have this check here? Well, I can say either you give me the cat name, or if the cat name is null, then I have what we call the Elvis operator, okay, question mark colon, and I put here a default value, so no cat available, or something to that effect, right? This is the Elvis operator, right? It's called Elvis because if you kind of tilt your head, it looks a bit like Elvis with his hair up. Some people see it, some people don't. But anyway, we have cat name, no cat available. So if my cat name is null, as it is in this particular case, if I run that, I will get no cat available, whereas before I would get null. Okay, so this allows us to provide a value in case the value is null for my variable. Now, what happens if we as developers know that there is a value there, it's not null, but the system doesn't know, okay? We have some complicated process that comes from a database or whatever, or a network, and we are sure that we have a value. Well, we can say cat name !length. Okay, so that tells the system, look, I know that this seems like a possible null value, but I am certain that it has a value there. So just trust me and move on with your life, right? Move on with the program. Now, this is a very, very tricky and a very risky one, and it's commonly, it's not very recommended. You shouldn't really use this unless you absolutely have to, because this can, in fact, provide you with null pointer exceptions. So in my particular case, it actually does. So if I run this code, the value is null. I tell the system that, trust me, there's a value there, and there is no value there. So I get a null pointer exception, so I get a crash, obviously. Okay, so be very careful when using this operator. It's not really recommended to use it, but it's there if you do need it. I have come across a few situations where I do need it, but they are quite rare. All right, so let's move on. We have collections. Okay, so let's talk about collections. We have three main types of collections in Kotlin. We have lists, we have sets, and we have maps. Okay, the list is basically what you would expect, a list of values. Importantly, all the values in the list must be of the same type. Okay, so if we put strings, we put all of them strings. If we put integers, all of them must be integers. Okay, so let's go ahead and define one. Let's say animals equals. Now, in practice, we're going to define what we call an array list. So array list of, we don't need to put the type there, don't worry about that. Array list of, let's say, cat, dog, and hamster. Okay, now if I try to put a integer here, 5, fuck. Now the variables in the, or the values in the list can be of any type, right? It doesn't really matter, they don't need to be the same. So let's go ahead and define one. Let's say val animals. Now in practice, we usually use an array list. An array list is basically a list with an ordered set of elements, right? An ordered element list. Okay, so we have a first element, second element, third element, and so on. Okay, so we're going to define an array list. We can remove those, the type there. We don't need to worry about that. We have cat, we have dog, and we have hamster. Okay, so this is my list of animals. Okay, let's go ahead and print it. Animals. I'm going to run it. So importantly, in a list, okay, I still have that crash there. Okay, let me run it again. So like I said, importantly in a list is that there is an order in an array list, right? That's an array list. There is an order of the elements. So this is the first element, second, and third. Obviously, in any, or maybe let's say most, I don't think there's any exceptions, but in all of programming languages, all the programming languages store elements starting with element 0, okay? So here, if we want to print the first element, we're gonna get animals of 0. Okay, so we're gonna run that, and we get cat. There we go, it's the first one. If we do 2, we're gonna get hamster. Okay, if we do 3, we're gonna get a crash. Okay, index out of bounds exception, as we were expecting, there is no element 3. Okay, so that is a list. Now let's talk about a set. Here we have, let's say, days. Now the important thing in the set is that we have only one, or rather the elements are unique, okay? We cannot have duplicates. Here we can have cat, dog, hamster, and again cat, that's fine. In a set, we cannot have that. Okay, so here, let's say days equals set of, let's say, Monday, Tuesday, and let's say Monday again. Okay, we can add it there, but if we try to print line the days, we're only going to get Monday and Tuesday. Okay, Monday, Tuesday. The order doesn't matter. Okay, the set doesn't guarantee us an order of the elements. I think we have a hash set of, but I'm not sure that one guarantees order as well. Anyway, so the order is not guaranteed. The element uniqueness is guaranteed for sets. The other type of collection we have a map. Let's define a map of, let's say, a dictionary, right? So dictionary is an example of a map. Let's say hash map of. Now, a map basically converts one value into another, okay? So it maps a value to another value. So here we have a dictionary from, let's say, English to Spanish. In order to define that, we're going to use a type pair. We're going to do the English version 1 and the Spanish version uno. Okay, another pair, 2, and we have dos, and another pair, 3, and we have tres. So here the first element is called the key, the second element is called the value. So we have key value pairs. Okay, that is a map. Now if we want the value here, we can say print line dictionary of, let's say, 2. Okay, run that, and we get dos. Okay, now the keys are a set. Okay, so we cannot have multiple same key multiple times. The values are a list. Okay, so we can have duplicates here. Okay, so those are the main list. There's a lot more to be said about them, but I'm going to limit it to that. Now, let's go ahead and talk about loops, specifically the for loop. Now, let's say if I want to print out a message for each of my animal, how would I do that? So we have this structure for, a for loop, let's say pet in animals. And here I have a variable pet that will go through each element here. Okay, so I can print line, I have a $pet. Okay, running that, we will get 3 messages for the pets. Okay, I have a cat, I have a dog, I have a hamster. What if I want to loop through the set? That's exactly the same way, except the order is not guaranteed, like I said. However, what if I want to loop through the hash map? Okay, let's have a look. For, now here I need to provide a key variable and a value variable. So here I have en and es for Spanish in dictionary. and I can print line something like $en in Spanish is $es. Okay, let's run that. Okay, so 2 in Spanish is dos. Like I said, the keys are a set and the order is not guaranteed. So we get 2, 3, and 1. Okay, 2, 3, and 1 is uno. Okay, that is fine. Okay, what else can we say? Let's talk about the if statement. The if statement allows us to make a decision based on a logical condition, okay, a logical expression. So I can say, let's say if 5 greater than 3, print line, math is easy. Okay, so let's run that. That's going to give us true. If that's true, we're going to get the message here. All right, let's do something a little more complex. Let's provide a, for instance, like we have this for loop here. Let me just copy that. I can say if my pet is a cat, then, without the dollar here. So if my pet is a cat, I'm going to print line the message, I don't have a cat, have a pet. Okay, so what will happen here? Well, we're kind of correct that I don't have a cat, but then I get the I have a cat message as well. So how do we do that? Well, we have multiple branches possible on this if. So for instance, if pet equals cat, we do something else, we do something else. Okay, let me run that. There we go. So I don't have a cat, but then I'm not getting the I have a cat message. I get I have a dog, I have a hamster. Okay, so we have 2 branches to our if. But we can of course put multiple branches as well. So we can say if pet equals cat, else if pet equals dog. Let's say dogs are cute. Else, the default case, print line, I have a $pet. Okay, so let's go ahead and run that. And we can see that we have 3 different branches here. Now, of course, this is a bit of a pain. This is not very nice to build so many branches like this, because we have an easier way. We have the when structure. Okay, let me put that inside a for loop. So for pet in pets in animals, when pet. Okay, and here we can provide various values for that pet. So if we have cat, then we do something. Let's say I do this. Then if I have dog, then I do something else. I do this. I just print line this message. And then if by default I have the else case where I can do this. Okay, so that should give me the exact same result as the if statement. Okay, so I don't have a cat, dogs are cute, and I have a hamster. Okay, so that is the for loop, that's the if statement, that's the when. What else do we have? Okay, so finally we're going to talk about functions. Now, functions are a way to encapsulate functionality in a certain way and call it multiple times. So let's say I want to declare a function that prints out a message, okay? And I want to call that, let's say, 10 times, okay? Instead of calling the same print line message 10 times or printing it 10 times, I would just put that in a function. So we define a function with the fun keyword. Let's say we give it a name, print message. Here we have parentheses. Inside, we're going to see how to add parameters and the block of code surrounded by curly braces. Okay, so here I'm just going to say print line, hello, John. Okay, and I want to call this 10 times. Let's say I do a for loop from I in 1 to 10. 1 to 10 is simply a range. Okay, it allows me to go from have a value from 1 to 10, 1, 2, 3, 4, and so on. Okay, and here I have print message. If I run that, what do I get? I get hello John 10 times. Okay, I can even print here without print line, just print I, and that's it. Let's see what that gives us. Okay, 1, 2, 3, 4 until 10. Okay, so that is how we define a function, and a function can basically do anything you like. You can encapsulate a little functionality, a lot of functionality, pretty much anything you want in a function. Okay, now there's two more things I want to talk about in this video. There's a lot of things that could be said about functions, but I want to show you how you can customize the functionality, the operation of a function. Let's say I'm going to change the name I want to print hello to. Okay, so let me just remove that, or instead of removing it, I'm just going to comment it out. And here, let me define names as a array list. Alice, Bob, Carol, and Dan. Okay, so I have 4 names. What I would like to do is I would like to get a hello message for each of my users, right? So I could say for name in names, okay? And I want to print message. Obviously, this is a very simple function, so we could put the message here, but let's say this is a very complex functionality that provides us with a much better message, okay, than a one line. Print message, and here I want to pass the name of the person that I want the message to be addressed to. Okay, so how do we do that? In print message, we will receive that name. So let's say person, and we need to give it the type here in the function definition. Okay, so here we have a variable person as a string. Okay, and we are free to use this variable inside this function. Okay, so instead of hello John, I can say hello person. Okay, I'm going to use the variable here. Let's go ahead and run this. And we're going to get hello Alice, Bob, Carol, and Dan. Of course, this functionality can be much larger, like I said, and that will make it more interesting to use as a function. What we also can do is we can return a value from our functions. Okay, so let's say I'm going to define a function called calculate an amount. Okay, let's say we have a value here of type integer. By the way, you cannot name a variable val because that is a restricted keyword. Val means something in Kotlin, so be careful about that. I called it value. Okay, it's an integer. So let's say we want to just apply some math operation to this and return the result. So here I'm going to return, this is the keyword for actually returning a value. Before that, I'm going to define a val result as, let's say, value times 5 divided by 3 plus 8 mod 5 multiplied by 27. Just completely random, it doesn't really matter. So here I'm going to return a result. Okay, and in my main program, my main function, let me just define a val, let's say account values, an array list, and here I'm just going to put some random numbers. Okay, let's put 5 numbers. Okay, there we go. So we have our 5 numbers, and I'm gonna have a for loop, ACC for account values. Okay, and here I'm gonna call the function. Now, importantly, if we return a result here, then we need to define the type of the result that we're going to return. Okay, so here I'm going to return a long, let's say. This is an int. Okay, let's define an int here. Okay, so that is how you return a result. And then here I'm going to print line some message. I'm going to say $ACC is converted to $calculate amount of ACC. So if we run that, then we get the values. They are completely random. They don't really mean anything, okay? There is another way to, it's kind of a shortcut for simpler functions that just want to return a simple value from a input, okay? So if we want to make it as short as we can, as short as possible, you don't necessarily need to do this because they are equivalent. Let me just duplicate this, and I'm going to comment out this part of the code, and I'm going to refactor this to make it as short as possible. So I'm going to take this and put it right in the result. Okay, I'm just going to add it there. So this is going to calculate the functionality and simply return it. However, we can actually eliminate this return keyword. We can eliminate the return type. We can eliminate the curly braces, and we can simply say this value, this function equals this value, okay? Since it's a one-line function, then we can simply return the value that is resulted, and the return type will be automatically inferred by the system based on the type of this operation, okay? And if we run that, it is exactly the same functionality, the same result, okay? So we get here the exact same result here. Right, so of course there's a lot more to be said about functions, about a lot of these concepts that I've discussed here, but I hope that has given you a basic idea of how you develop functionality in Kotlin, you know, starting from, let's say you have some experience from another programming language. This is the Kotlin flavor of that functionality, but with a few added twists like the null checks and things like that. Now, again, I don't have so much time in this short YouTube video. I have covered as much as I could here, but if you want to learn more about Kotlin, I have a much larger course. It is more than 30 hours of videos that I've put a lot of effort in, both in creating the content, the videos themselves, but also the knowledge that I have accumulated throughout the years working in Kotlin development. So if you want to learn more about this, check out the link in the description. I will put a link with a sizable discount to my video course. So have a look at that. And yeah, just start using Kotlin. Even if you don't know everything, even if you don't understand anything, the more you use it, the more you will learn and the better you become at it. So go ahead and start using it. I hope you've enjoyed this video. I hope you found it useful. If you did, please give it a like and subscribe for more content like this. Thank you for watching, and I'll see you in the next video.